a kitchen item. So you click kitchen item and it filters a lot of things.
Hmm.
And then you click, okay, I want something for, I want a, let's see, I want something for the stove. So you filter to stove items, and then you filter to, stove. You filter to pans, or so it's basically a process of filtering.
Hmm. Okay. So how does the filtration happen? Through extra demands, right?
Yeah.
And every parallelogram is a trapezium, right?
Yeah.
So would all the properties of trapezium be possessed by a parallelogram?
Yes.
Would all the properties of humans be possessed by an American?
Yes.
Would all the properties of an American be possessed by a Texas person?
No.
If say
Yes. 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 Yes.
if every American is supposed to have a passport, right? So would every Texas person also have a passport then?
Yeah.
If every Texas person gets a say a red colored badge, does that mean every American will get a red colored badge?
No.
That would then be a unique property of Texas, right?
Yeah.
So whatever properties we see in a parallelogram, they're also possessed by which all shapes?
Wait. Could you please repeat that? Sorry.
All the properties of a parallelogram, all the properties of a parallelogram, they're also possessed by
Hold up. They're possessed by
their inherit
rhombus and rectangle.
and
Square.
exactly the grandchild also, no?
Yeah.
So there's inheritance of properties.
Yeah, that's right.
So all the properties of a polygon are possessed by
All the properties of a polygon are possessed by a quadrilateral.
and underneath us.
And then trapezoid, then parallelogram, then rhombus, then rectangle, then square.
Correct. And who has the highest number of properties of the lot?
Square.
Because they say, right, every generation is smarter than the previous generation.
Yeah, cause there's more knowledge and more stuff to know.
Exactly. Like your parents pass on their knowledge to you.
Yeah, and then we learn more knowledge from like scientific discoveries.
Exactly. And all of that gets passed on. So generation by generation, the smartness is going
Yeah,
up.
that's correct.
So in that sense, the square is accumulating highest number of properties. Now, Nishant, is it easy to solve a problem about a square or about a rectangle?
Square.
And why would you say that?
Because all the side lengths are the same and all the angles are equal, are 90 degrees.
Okay. Let me ask this question a little differently. Let's say you work for the FBI and you're trying to catch someone. There's one thief, like 100 things about him. There's one criminal, 100 things about him. There's another criminal, you probably know 2 or 3 things about him. He is very unknown. There are no records. Who is easier to catch?
Criminal with 100 records.
And why?
Because you already know a lot of information about them. You can plan their next move.
Right. So you know a lot of
Like
information.
you can predict. You can predict.
Correct. So likewise, can we extend this analogy to rectangle and square?
Yeah, so since we know a lot of properties about a square, then it will be easier to find exactly. Since we know a lot more about the square than the rectangle, it will be easier to solve an equation about a square.
So would a symmetric shape be a delight or an asymmetric shape be a delight?
What does delight mean?
Delight as in something which you would love to do.
Symmetric shape, easy. Huh?
Why would a symmetric shape be more delightful?
Because the same thing, an asymmetric shape would kind of be unconvenient. Like it would, a symmetric shape would be more convenient to solve with because if it's symmetric, then you know more properties than if it's asymmetric.
Okay. So do you see why physicists and mathematicians love symmetry and search for symmetry everywhere in nature?
Yeah.
Okay. Now, okay. So tell me one property of a parallelogram which we saw, which you also submitted as a part of your homework, I guess. No, not last week. I mean, last class we derived it. Property of a parallelogram.
Yeah. Okay.
Tell me the properties which we derived for a parallelogram. One property is,
Opposite angles are equal to each other.
so for a rhombus, would that be true?
Yes.
For a rectangle,
Yes.
square.
Yes.
Okay. If you are in say fifth grade, would you be able to tell me that opposite angles of a square are equal?
Yes.
Why? Because they both are equal to.
90 degrees.
Great. What is the other property we saw for a parallelogram?
Opposite sides are equal.
Would that be true for rhombus?
Yeah, but at the same time, all four sides are equal.
So that yeah, rhombus is more. It's satisfying more.
Okay.
In a rectangle, are opposite sides equal?
Rectangle and opposite side equals. Yeah, same thing. Yeah, they're equal.
Yeah. In a square,
All four sides are equal.
it's inheriting rhombus property of all four sides being equal. Now, what is the other property? Opposite sides equal, opposite angles equal. There was another property we saw. The two diagonals of a
They bisect each other.
right. And are the diagonals equal?
No.
Not necessary. In a rhombus, are the diagonals equal?
Yes.
How can we prove that the diagonals are equal?
Yes. Here, let me do this for you. Hold on. Can I annotate?
Which two triangles are congruent in a rhombus here? I'll number them for you. 1, 2, 3, 4. Which two triangles are congruent? 1 and
1 and 4. That's easily said. But I can tell you something third.
yeah.
So this side is equal, okay?
Hmm.
And then rhombus forms 90-degree angle, okay?
Rhombus doesn't form 90. It is square which forms 90. Rectangle and square
Oh,
90. Oh yeah, there it's 90. Correct. Yeah, it forms a
yeah.
center. Yeah.
Yeah, 90-degree, and then we have a side.
Hmm.
And then since we know that parallelograms bisect each other to form midpoint, we know that these sides are equal. So side angle side. Simple.
Yeah, but 1 and 2 are not congruent.
Oh, side number 1 and 2.
Oh yeah, 1 and 2 would also be congruent. No, correct.
Yeah.
Why? Because this side is common, the hypotenuse is same side equal. So 1 and
Yeah.
2 are congruent. But if 1 and 2 are congruent, can you say that these two diagonals are equal? Is this x equal?
Yeah. CPCTC.
Yeah, CPCTC tells you that corresponding sides are equal. But can you say that if this is x, this is y, can you say x is equal to y?
No, unless.
So in a rhombus, you can have the diagonals being not equal. But in a rectangle, are diagonals equal?
No.
Pythagoras.
But actually, yeah. Yes, they are.
Both are under root x square plus y square, no?
Yeah.
In a rhombus, diagonals are not necessarily equal, right? This could be x and this could be y, and yeah, this would be under root x square plus y square. Why? Because diagonals bisect each other for at 90 degrees for a rhombus. In a rectangle, do diagonals bisect at 90 degrees? Not necessary, right?
Not necessarily, no.
But in a square,
Yes.
because it inherits the property of,
Rhombus.
in a square, diagonals are equal and they also hit at 90 degrees.
Okay.
Hitting at 90, it gets it from rhombus. It's like this is a mother, this is a father. It gets at 90 degrees from the mother and gets the equal diagonals from the father.
Oh, okay.
gets one property from here and one property from here. And what is a grandfather property in a parallelogram? Both the diagonals.
All the diagonals are. Wait for. Can you wait for what? For parallelogram?
Both the diagonals.
Bisect each other.
Correct. That is a parent property. Now you see how we go about maneuvering between the properties of different shapes.
Yeah.
Largely, we are interested in these four shapes because trapezium has two less properties to be interesting.
Okay.
Because in a trapezium, opposite angles are not necessarily equal. Sides ka you can't say anything. Diagonals ka you can't say anything. You can't say much about a trapezium except for using parallel lines, alternate angles and all of that you can use. But apart from that, you can't do much with a trapezium.
Okay.
So what did we see? Diagonals bisect each other, diagonals being equal, diagonals hitting at 90 degrees.
Yeah.
Okay. Okay, now let me give you a problem. There is a rhombus with side length 13 centimeters. One diagonal has length 10 centimeters. Find the length of the other diagonal.
Okay. Oh. So the diagonal is 10, correct?
Yeah, the diagonal is 10.
Okay. Okay, so I need to prove that this diagonal is congruent to this diagonal. Okay.
No, I just want you to find the length of the second diagonal.
Okay. Okay, so that's 13 and this is 10. Oh, I don't know how to do this.
Think. What do you know about a rhombus? The diagonals?
Are equal.
Are they equal in a rhombus?
No. Yes, in a rhombus and square.
The rhombus, the diagonals only bisect each other at?
Or 90 degrees, okay.
And in a rectangle, diagonals are equal.
Oh, okay.
So the diagonal bisect at 90. Do you know one of those sides in that right angle triangle?
Okay, so this is okay, yeah, this makes sense. Okay. So this bisects and this is 13 and this is 10. So that would be 169.
Hold on a sec. What is 10?
This one.
Diagonal is 10 or?
Okay, it's 13 and 5. Okay, so then that means that this is 12. That means that this is 12 and then this other length is 12. So 24. Simple.
So what's your reflection from this problem solving experience?
Since you can use Pythagorean theorem.
No, but in terms of your approach, what lesson would you learn from this problem? You said I can't do it, but then you realize it's very simple. So what is the lesson you could derive from here?
You should look at other details. For example, I didn't look at the detail of that there were right angles within it.
Right. So now can you draw a mind map with all the four shapes? I'll clear the screen for you.
Okay.
What properties come in at each stage? The unique property which comes at each stage. Parallelogram then.
Hold on. Let me do.
Nice. Well done, Nishant. Yeah. Next one, rhombus. Yeah, but what extra properties get added for rhombus? In Nishant, there are just one more property for rectangle and one more property for a rhombus. Okay. Rhombus is done, diagonals bisect at 90 degrees. For rectangles, diagonals bisect each other. Diagonals are also equal, no, in a rectangle. How do we prove that the diagonals are equal in a rectangle?
Pythagorean theorem.
Good.
Finished.
Square diagonals of equal bisect, all angles are equal. Sides are also equal, no?
Oh yeah, I forgot that.
And all these properties are derived from congruencies, right?
Yeah.
In a parallelogram, which all, can you draw a parallelogram and the 4 triangles with the diagonals? Draw a parallelogram and the 2 diagonals. The 2 diagonals.
Oh, two diagonals. Okay.
Yeah. Yeah. Now, which triangles are congruent?
This one and this one.
Opposite triangles are congruent. How will you prove that they're congruent? Sides are
Okay.
equal.
Vertical angle and then opposite side, and then angles bisect each other, so side, side, side.
No, that bisecting ke liye you're using the congruency. Two sides vertically opposite angles, and the third angle is, the second angle is alternate angle, right?
alternate. Yeah, alternate interior angles.
Yeah. Next, come to a rhombus. Draw a rhombus with the 4 triangles with the help of diagonals.
Okay, so diagonals bisect each other. All sides are equal.
So which triangles are congruent in a rhombus?
All triangles are equal?
Correct. Now draw a rectangle with the 4 triangles. Now, which triangles are congruent?
Opposite triangles.
Yeah. Now draw a square. Which triangles are congruent?
Let's see. What triangles are congruent? All triangles are congruent.
It inherits this from rhombus, no?
Yeah. Yeah, it does.
So with the help of this diagram itself, can you visualize all the properties?
Okay. Yes.
All these properties, they come from congruence only. Now, how do you prove that opposite sides of a parallelogram are equal? Now, these are 1/4 triangles. No, for that property, what triangle do you consider? I'm calling it 1/4 triangle because it's like 1/4 of the whole piece. So for proving opposite sides are equal, what triangles do you use?
Opposite triangles.
You use half triangles, no?
Oh yeah, half triangles. Oh yeah. And then this side is equal to itself, and then this side is equal to this.
By
Wait,
CPCT. But how do you prove opposite triangles are congruent? What property you use?
angle side angle.
Yeah, how? Which side is equal in both? Half
Alternate interior angle, and then side is reflexive.
correct. Good. So now are you able to see entire quadrilaterals at a glance?
Yeah. Yes.
Yeah, a lot of people take 4 classes, 5 classes to study this, but if you can see it as a mind map,
Yeah, I can.
we just have to study the inheritance here.
Okay.
How does inheritance make it easy to visualize all the properties?
How does inheritance make it easy to visualize all the properties? Uh, hmm. Oh, okay. Well, because they have shared properties.
Right. So does it give you a more minimal thing to look at and to remember?
Yes.
How?
How? Oh, yeah, that's a good question. Okay. How is because you can see like it's kind of here's the thing, Tharan. Like this is how like most people like do it. So they see all the similarities for two things, and then they see the common differences.
Hmm. Okay. So, okay, now let me give you a question, Nishant, a very easy question. Nishant, I'll give you the side and the rectangles. You need to tell me what shape it is and you need to prove it. Okay. So, the side length is 25.
Okay, for what?
There is a quadrilateral. There's a quadrilateral. So,
Okay.
one side length is 25.
Okay.
One side length is 25. One diagonal's length is 40. The other diagonal's length is 30. What shape is it and why?
So it can't be rhombus or square
Okay, and why would you say that?
because the diagonals are equal.
Are the diagonals equal? One diagonal is 40 and the other diagonal is 30. So
No, because in the rhombus and square, the diagonals are equal. However, in the parallelogram and rectangle, they aren't equal.
in a rhombus, are the diagonals equal?
Oh, no, I mix it up. No. The rhombus.
What can you,
No. The rhombus diagonals aren't equal, but the rectangle is equal. Okay.
so it cannot be a square, it cannot be a rectangle, no?
It can only be a rhombus or.
Yeah,
Okay,
but
so now we know that it's a rhombus or.
25,
Oh,
40 and 30, what pattern do you see?
huh?
25, 40 and 30, what pattern do you see?
I'm drawing it out. Okay, so this is, and then so they bisect. Okay, so let's say this is. Wait, hold on. So this is 40 and this is 30. So then that would be 15 and 20.
So by converse Pythagoras, that should be
90
degrees, so a rhombus.
Exactly.
Okay. Now, can you find the area of a parallelogram? Erase the screen. Clear the screen. Can you prove that the area of the parallelogram? Can you rearrange the parallelogram to make a rectangle? Draw a parallelogram. Can you cut some pieces and rearrange to make it a rectangle? What pieces would you cut?
Diagonal.
Right. So
Like
can you prove that these two? Can you prove that these two pieces are congruent?
Yes.
How?
Just check the area.
If two pieces have same area, they're congruent. If two
Oh,
have same area, do you mean you can overlap them exactly?
no. Oh yeah, that's not correct.
How do you prove congruence here of these two triangles?
Okay, first you need to check the height of this. So then this is, let's say this is 15, okay? And then this, wait, actually no, let's say this is 12 and this is 5, okay? Then this would be, and then this is,
To prove two triangles are congruent, what is your strategy usually?
SSS, SAS.
Exactly. So to prove these two triangles, what property would you want to use? You know one is a 90. So
Side. Oh wait, side angle side, because this becomes 90 degree.
So you have 90 degrees in both the triangles, then
290. Okay, then I have to check if this is 5.
yeah, that is a little tricky, but can you look at anything else which you already know? Opposite sides of a
Oh
parallel.
yeah. So since we already know the side length, we need to know this side length. Okay.
What do you know about opposite sides of a parallelogram?
Opposite sides of a parallelogram are equal. So this must be equal to this.
Right.
Wait.
And what do you know about distance between parallel lines? Distance between parallel lines is always
Distance between parallel lines is always equal.
so that height 1 and height 2 are the perpendicular length there and perpendicular length here. Height 1 and height 2 are
Equal.
so you have hypotenuse, you have a side, and you have got a right angle, right?
Yeah. So you prove that it's equal.
You prove that both the triangles are
Equal.
congruent.
Congruent. Oh yes.
So which means that I can take this piece and shift it here. So can you draw the new shape after the shifting is done?
Can you draw a new shape after the shifting is done? Okay.
Yeah. Now what is the length of the shape and what is the breadth of the shape?
Let's say this is 10.
Now, if the original parallelogram length was L, breadth was B, and height was H, what will be the dimensions of this shape? Original parallelogram length was L, breadth was B, height was H. What will be the dimensions of this shape?
H by L.
H by L, right? So B is gone.
Yeah.
So what will be the area of a parallelogram?
The area of a parallelogram.
Can you describe the area of this rectangle?
One half of one half. Wait. Height times length.
What can you tell about the relationship between? What can you tell about the relationship between area of the rectangle and area of the parallelogram?
Oh, so in parallelogram, you have to multiply length times height, okay?
Hmm.
And then you have to multiply length times width, length
No,
times height. So it's the same formula.
no, are you using the formula you're telling me, or by logic you can tell me that their areas?
Yeah, by logic.
How?
It's simple, all you just do is
You're just shifting the
yeah, you're just shifting it. You're just shifting the triangle in your head, and it's simple.
correct. So area of a parallelogram is length into height.
Yeah.
Now can you find the area of a triangle using this? If a triangle has base H and base B and height H, clear your screen.
You need to clear your screen too.
Oh yeah. Yeah. Draw a triangle with base B and height H.
Base B and height H, okay. It's actually pretty simple to find it because if you do this, then it's going to be the same. So it's actually half of a square. So it's one half
Yeah,
of
but
B8.
draw a right angle triangle. Draw
Yeah,
draw a general triangle.
a general triangle. Okay.
Draw a triangle which is not right angle. Yeah, base B and height H.
Yeah. Oh, base B and height H. Okay. Height. This is base, and this is height. Okay. Okay. So base B and height H. Okay.
Hmm. Now how do you do? Can you take help? Can you create a parallelogram here? What if you double this?
Yeah, you can. I mean,
Use a different color and double this. Yeah. Will this become a parallelogram when you double it?
no, it'll be a rhombus.
In the triangle, are all the sides equal?
Yes.
See, in every triangle, all sides are equal.
Well,
So does it have to be a rhombus?
no, that doesn't make sense.
Yeah, but how can you claim that this is a parallelogram?
How can you claim that this is a parallel? Because
Are opposite sides equal?
yes,
Are opposite angles equal?
yes.
Because it's the same congruent triangle, no? You just put the,
Yeah, you just flip it and add it.
yeah. So it's a parallelogram.
Yep.
So what will be the area of a triangle then? Half of the,
Half of the base and height.
why? Why is it half?
Because you're just multiplying it by 2.
Yeah, because the area of the triangle is half of the area of the
Half of the area of the parallelogram.
Yeah. Okay, great. So now Nishant, let's do the next thing. Let's say I give you a quadrilateral with opposite sides equal and opposite angles equal. Can we prove that it's a parallelogram?
Wait, a parallelogram?
There's a quadrilateral, opposite sides are equal and opposite angles are equal. Can we prove that it's a parallelogram?
Okay, so opposite sides are equal and opposite angles are equal. Okay. Yes.
How do you prove that it's a parallelogram?
Okay, so we're just going to draw a quadrilateral. Opposite sides are equal. And then opposite angles are equal. Okay, yeah.
So I give you a quadrilateral, opposite sides are equal, opposite angles are equal. Can you prove that it's going to be a parallelogram?
Yes, yeah, because I just said, yeah, because opposite sides are equal. Yeah, I just proved it.
Now, how did you prove it? You only know opposite sides and opposite angles are equal. How do you prove that it's a parallelogram? I know that if it is a parallelogram, opposite sides are equal and opposite angles are equal. Now I'm asking you to prove reverse,
Oh,
converse.
so we need to prove that how this is a parallelogram?
Yeah, you have to prove that now the opposite sides are parallel. How do you prove that?
Let's see. How do you prove? Ah, crap. I don't know. I forgot. I'm sorry. Hello, Darren.
So now let us assume that, see, we'll use a strategy called proof by contradiction. Can you clear your screen and draw it neatly again? So it's a little easy to work with.
Draw the parallelogram again. Okay.
Now let us suppose that this is not a parallelogram. Okay, they only told us that opposite sides are equal and opposite angles are equal, right?
Oh yeah.
Let us say it is not a parallelogram. If it's not a parallelogram, then you can draw another. Let's say these two lines are not parallel to each other. Then you can
Mhm.
let's say, I mean, we're proving opposite, right? Let's say
Yeah.
these two lines are not parallel. Then you should have another line which is parallel to the baseline. Now, can you with another color, can you draw another line which is parallel to the base?
Okay.
If this is not true, you should have another, no, but passing through the vertex, passing through the top right corner vertex.
Like this.
Yeah, top right, it should pass through top right corner vertex and parallel to the base.
That.
No, it should pass through the top right corner. No, this is not passing.
Oh, type like here.
Yeah. Yeah, just one moment. See, Nishant, let me show you this proof.
Okay.
What they told us is it's a quadrilateral.
Mm-hmm.
Opposite sides equal. and opposite angles equal. Proof by contradiction. Let's say it is not a parallelogram. We will assume the opposite. Then
Okay.
we have another line like this which is parallel to the base. We will say green is parallel to the base. Why? Because they said it's not a parallelogram. We're proving, we're proving by contradiction. What is proof by contradiction? You assume the
Okay.
opposite is true and you contradict yourself.
Okay.
So we say green is parallel to red. If green is
Okay.
parallel to red, what can I say? If this is double angle, then this is supposed to be the double.
Wait, what does that mean?
Alternate angles, no, because they said green is parallel to red, no.
Yeah. Oh, yeah.
So then sum of these two angles is 180.
Yeah.
And now, do we have a problem there? Do we know that? See, we know opposite sides are equal.
Yeah, we do know that.
And we know these two angles are equal. And then, if I continue this red, this should also be the double angle. Which means that the single angle plus double angle is less than 180, right?
Yeah.
If single angle plus double angle is less than 180, it means the sum of angles inside is less than 360,
Yes, that's true.
which means it's not a quadrilateral.
Yeah.
You got my contradiction?
Yes.
If these two were not parallel, it's parallel to somebody else.
Okay.
But then they said,
Oh, okay. Yes, that means it has to be another factor. Okay.
so
Got it.
then there's some other theta here, which means these two are less than 180, but these two cannot be less than 180. These two have to be exactly equal to 180. See, if Nishant, if this is x, sum of all, then this is also x, this is also y. Then what do you know? 2x plus 2y is equal to 360, because sum of angles in a quadrilateral is 180. So you know x plus y is 180. If x plus y is 180, how much is this?
X.
If they just tell you opposite angles are equal. If they just tell you opposite angles are equal, you don't need opposite sides also. If they tell you opposite angles are equal, this is x, this is x, this is y, this is y. You know x plus y is 180. Why? 2x plus 2y is 360. If this is y by linear pair, how much is this?
X.
You are having alternate angles being equal. So these two sides are parallel.
Okay.
So if you know opposite angles are equal, that's enough. That is a parallelogram.
Parallelogram.
If pairs of opposite angles are equal, you know it's a parallelogram. That's a property. By next class, I need you to write this proof in your book and submit it. Okay. That if pairs of opposite lines are equal, it's a
Parallelogram.
next. What if we only know that opposite sides are equal? Then what if we know this, can we prove it's a parallelogram? Only opposite sides are equal. Then what can I say about these two triangles? If these opposite pairs are equal, what can I tell about these two triangles?
Then it's SSS. They're both of them are equal.
So this x and this x are
One are alternate interior.
no, they are not alternate interior because I didn't tell you the parallel. They are now CPCT.
CPCTC. Okay.
So now these two angles are equal. If these two angles are equal, then these two lines should be parallel.
These two are parallel. Yeah.
Because the alternate angles are being equal.
Okay.
The opposite. If lines are parallel, alternate angles are equal. If alternate angles are equal,
Then lines parallel.
exactly.
Alternate interior angle converse.
Yeah, exactly. So what did we say? In a quadrilateral, if opposite sides are equal, It is a, if opposite sides are equal, the parallelogram, the quadrilateral is a parallelogram. How? These two triangles are congruent, by CPCT alternate angles are equal.
Okay.
You got the argument? If
Got it.
I tell you that opposite sides are equal, then these two triangles are congruent by triple S. Because these two triangles are congruent, the alternate angles are equal by CPCT. Because these alternate angles are equal, the lines are parallel.
Okay.
Now likewise, if I tell you that the opposite angles are equal, if I tell you that the opposite angles are equal, then I need x plus y, 2x plus 2y is 360. So x plus y is,
X plus Y is 180.
so if this is x and this is y, this should also be,
X.
so here again alternate angles are being equal, they're parallel. So if they tell you opposite sides are equal, it's a parallelogram. Or if they tell you opposite angles are equal,
If they tell you opposite angles are equal, then I don't know.
just now we proved, no, here, just 15
Oh
seconds.
yeah, then they were supplementary.
No, what did we prove? If opposite angles are equal, the shape is a,
Parallelogram. Oh,
what?
they're parallel, so then it's a parallelogram.
Yeah. Now, when you take your triangle like this, and you put a cousin piece of the, you took a take exact piece of the triangle and put it here. How can you prove that it's a parallelogram? Is this piece equal to this piece? CPCT? Corresponding.
Yes.
And is this piece equal to this piece? No, it's flipped, no? So this piece is equal to this piece.
Yeah.
And this piece is equal to this piece. So our opposite angles equal?
Opposite angles equal. Opposite angles equal each other.
Right? Because it's y plus z and y plus z.
Yeah.
Or this is one way of proving that when I put two triangles together, it's a parallelogram. Two equal triangles. Nishant, see here. What is one criteria? Because opposite angles are
equal.
Another criteria of doing this is, can I say opposite sides are equal? Is this side equal to this side?
Yes.
CPCT, because it's the same triangle.
Yeah. SSS and then angle. Okay.
Anyway, so these two triangles are opposite sides are equal. If opposite sides are equal, it's a parallelogram.
Wait, third, I have a question. So throughout this proving. Hello?
Yeah, go ahead.
So throughout this proving, we've been trying to prove that two triangles are congruent in a parallelogram. So if we prove that two triangles are congruent, will the parallel lines be parallel? Will the lines opposite lines be
If I put
parallel?
two congruent triangles together, they'll be parallel. That's what we're proving. No, if these two triangles are congruent, then opposite sides are equal.
Yeah.
And we saw that if opposite sides are equal, it's a parallelogram.
Okay.
Right? We proved a lot of results today. So Snehita will send you all those results. Yeah, Snehita, what are the results we proved today?
Today, from the beginning,
Yeah, from the beginning.
In a rhombus, if a diagonal is given,
no, forget that. That is a small. That's a problem. But results. Yeah, so we proved that.
How do you prove that diagonals are equal in a rectangle?
That we finished last.
So how do we prove that?
Yeah,
like if a quadrilateral is given and opposite sides are equal and opposite angles are equal, can you prove that it's a parallelogram?
See here, that's also a problem. Nishant, see here. You have to prove these two triangles are congruent. That's one result. And you prove that the area of the parallelogram is L into H. And the second result is if opposite sides are equal in a quadrilateral, prove that it's a parallelogram.
Okay.
Third result is If opposite angles are equal, prove that it's a parallelogram. Fourth result is,
No.
if I put two corresponding triangles like this, I mean two congruent triangles like this, the resultant shape is a parallelogram.
Okay.
These
Sounds
four
good.
results, and then the fifth one is the mind map of all, which you drew in the beginning. I want all these 5 things pasted on the group, on the WhatsApp group by your Saturday's class.
Okay.
Okay.
My turn.
So
Oh yeah.
Nishant, see, if you're clear with these basics, I'll give you some very tough Olympiad problems to solve.
Okay.
These are like raw material. If you're perfect with this, then you'll be able to do geometry, Olympiad problems very easily.
Okay.
Yeah. Chalo. Good night.
Good night.
Yeah, Snehita, question paper, I mean, some 4 questions, you keep them ready based on today's class. I hope you got a lot of MCQs.
Yeah.
Chalo, good day.
Okay. Bye. No, no.